Hello, everyone. My name's Logan Luke. I'm from Nelson Laboratories. I'm excited to talk to you today all about package validation, specifically trying to meet the requirements of ISO 11607. Normally, this is a topic that I would like to spend a lot more time on. So we're going to do a lot of very high-level understanding of this topic. If you would like to discuss this and more, and I always love talking about package validations, you can meet me over at our booth. We're in booth 1142. Just some of the things we're going to talk about today. We're going to give a general introduction to packaging, kind of pin down some definitions so we can all be on the same page with what we're talking about. Talking about package design, what you should keep in mind as you're thinking about every step of your process. A lot of people like to think about package validations once it gets time to do one, and that's the exact wrong time to do it. So we'll go into some of the reasons why we do that. Sample size is another big question I get all the time. How to actually run the package validation, and then just a few more things to think about. So let's go ahead and get started with the basics. Talking about packaging, there are a few things to keep in mind, and it's hard to, sometimes you mix them up, right? So the first thing we have is the sterile barrier system. This is usually what's in contact with your device. This is what is the actual barrier to your device that should maintain sterility. That's usually housed in some sort of shelf carton or shelf box, and that's just another protective layer. And then those usually are stuffed inside of the shipper box, and then that's what you go to market with. All of that combined ends up being the package system. So you're probably aware of a lot of these packaging designs. Pouches, trays, form, fill, seal, and header bags are kind of the bread and butter for what most medical devices are packaged in. You might have something unique that you don't see on here, but I would probably say that like 90% of all devices can be captured in one of these sterile barrier systems. So the whole point of the packaging, right, is to actually offer protection to the device itself. You can see our Oreos right there weren't very well protected, and so when you open them up, you don't want your device to be like those Oreos and be all sorts of jumbled and garbage, and you can't do anything with it because the packaging didn't do what it was supposed to. It's supposed to maintain sterility, right? You want to keep those pesky microbes out. You want to make sure that if the layers to your sterile barrier system need to offer any sort of protection against humidity, maybe you have electrical components or other things that would react poorly with the additional moisture, that needs to be considered when you're creating your sterile barrier system to keep those environmental factors out. And ultimately, too, your product has to be functional by the time it gets to the point that you use it, right? And I would maybe add a fourth category on there too, that if there's some sort of functionality of have you been to Costco and have you seen those new lids that they put on the drink cups? You don't need a straw. It's just like this little flap, and it keeps the ice away, and you get to drink it. Like, I see designs like that, and I just think to myself, these are engineers. They're doing their job. So that's kind of just another plus that maybe your package can offer on there, right? In addition to those three big things, any extra bonuses like that would be great. Your packaging itself needs to have some labeling on there, and these are required by ISO 11607, where you need to include, and my laser pointer isn't working on the TV, it needs to have identification on there. You need to have your product name, lot, description, the expiry. Someone knows whether or not they can use it if they pick up your package. If there are special storage conditions that's needed, maybe it's stored ambient versus refrigerated, that needs to be on the label. And then other coded sizings. If you have technical information, be it a barcode or a QR code, maybe your IFUs are included in a QR code. That's also information you can include on your packaging. And you also need to notate where or what method of sterilization was performed on your packaging. And you also need to know what is the actual sterile barrier. Sometimes I've seen these double pouch systems, right, where there's an inner and an outer layer. You need to know which one is intended to be the sterile barrier for your system. Other information you can include on there is your manufacturer's name and address, instructions to review your IFUs like we talked about, and then whether like what the intended use is. Maybe it's going to market and it's actually for clinical use versus maybe you're sending it off to a lab. It's not intended for human use at the time. Those things need to be made apparent through the labeling. So like I mentioned, ISO 11607 is this big guidance document that talks about all of these package validation requirements. It's split up into -1 and -2. -1 is going to be talking about the material, sterile barrier, and package system. And your -2 is your forming, sealing, and assembly, more validating your process. So depending on what you're trying to meet, you might have to reference -1 or -2. ISO 16775 is another ISO document that you can reference that kind of helps you navigate 11607. So let's talk a little bit about design, shall we? Package design, even though you're thinking about functionality of your device, you're thinking about sterilization method, package design needs to be considered at the beginning of the process. I can't count on how many I only have 2 hands, how many fingers people have come to us to perform a package validation, and then it just turns out, you probably should have thought about this way before where you are, because they've chosen a sterilization method that's not compatible with their packaging. Like for example, if you're looking at EO, EO is done by gas penetration. So if you're using, say, a foil pouch, it's not going to sterilize it, right? It's not going to work. If your product or your packaging is influenced by pressure changes as they're doing the injections for EO, that also needs to be taken into account. Maybe your seals or whatever it is, they can't handle those changes. And similarly, temperature is also a factor, right? EO is not as intense as steam, but it's still elevated temperatures that you have to consider. Also, EO residuals is something that we have to consider, right? So if your packaging material holds on to that EO, it's likely not going to be very suitable as a sterilization method. Radiation is also something you have to keep in mind when you're determining the materials that you're using. We find that with lots of plastics, they become brittle after a radiation cycle, right? So the risk there is that after you perform radiation sterilization and your poly pouch now becomes embrittled, perhaps now it's no longer going to maintain its integrity and it'll break or shear or shatter apart, and now microbes can come in and all of your sterilization is completely undone, right? We talked about steam a little bit. Also, it takes that temperature and it raises it to the extreme, because that's what's actually sterilizing your pouch, right? So if your packaging is made of materials that can't withstand those temperatures and it melts entirely, then it's all ruined. So those are all things that you need to keep in mind as you're developing your packaging, choosing your materials to make sure that it's compatible with the package system that you're presenting. Right sizing of packaging. So this is another thing that can impact whether or not your sterile barrier maintains its good sterile barrier. If something's too small, the pieces of your medical device might jut, protrude, have jagged edges that can breach the barrier, right? And alternatively, if you go too big on the very right there, what can happen is if you end up needing to fold your pouch and stuff it into its shelf carton, those folds can also create defects which will impact your sterility. So you have to keep in mind what's the right size for my package to make sure that it's a good sterile barrier. It's not impacted by my device inside or needing to put it in the shelf carton and getting ruined that way. So in that same vein, usually when we run these package validations, they come down to these 2 failure modes. Your device may not have actual sharps with needles or things like that, but if you have these rigid corners, it may rub and tear against the corners of your packaging and create defects that'll lead to sterility failures. In addition to that, if you have a product that's incredibly heavy and it's resting on one of those seals, that prolonged weight could slowly inch away at your seal until it opens entirely, right? And some of the things that we just talked about with sizing issues, if it has too much room in there, or too much room to move in there, all of that rubbing and friction might slowly degrade the packaging to the point where it creates defects that lose sterility. And once again, if you're folding it, those folds might create those sterility failures as well. So if you have something that has some of those components in there, right? Like if you have sharps that you need to restrain, there are lots of options that you can choose. If you look at that, like the screw in the top center there, that's a pretty common thing that we see is picking something that will keep it in place and prevent it from rubbing against that sterile barrier. There are sometimes in just below it, you can have these cardboard inserts that'll restrain your device and make sure they aren't jostling, moving around, and causing those failures too. The last thing to talk about is just the shipper box. This isn't necessarily going to, it's not acting as a sterile barrier, right? But how full you load your shipper box can affect how much your cartons are shuffling around in there, right? Kind of those same principles of restricting movement and keeping it exactly where it needs to be throughout all of transit will make sure that it arrives without much damage. The fluting, which is the like zigzag pattern between the cardboard layers, comes in different sizes, A, B, C, E, and F. Your higher flutes have more steeper angles. So if you're thinking about shipping on like big pallets, right, maybe you want a higher fluting strength so that as they're all stacked on top of each other, the ones on the bottom aren't being compressed and now you've squished and ruined all your product on the bottom. You can also get your corrugate in double or triple wall strengths, and that'll also increase your compressive resistance. So you can certainly go overboard and create the most extensive, robust package system that you can think of, right? But that's not always going to be very feasible because we're running a business and you need to make sure that you're managing your costs appropriately. So as you're thinking about costs, you think about how much is enough. Can you get away with removing an extra layer, not having double walled? Can you do single walled? A big topic, which is why I wanted to bring this up in this forum today, was the medical device conference that DuPont just hosted at the beginning of October, was largely focused on sustainability, and EU has lots of regulations where they're encouraging and requiring packaging to become more sustainable, meeting certain recycling requirements and things like that. On the flip side, it gets really risky. You have to take into account what I mentioned at the beginning, which is how much is too much, how little is too little. You've got to maintain your sterile barrier system. It has to survive the trip, and you can't go overboard. The big thing that I like to keep in mind is that the protective layers, so thinking about the card, like the shipper box and the shelf carton, those are there to protect it, but really your sterile barrier, when you think about it, is intended to be strong enough to make it on its own for the last 100 yards. So if it goes and sits in the hospital until it's being used, it might just be in its pouch or tray or whatever it is. Can it survive the trip to wherever it needs to go in the hospital? So that's an important thing to keep in mind. There is a new requirement in ISO 11607. I say new, this has been in there since 2019 at this point, so it's getting to the point where it's not very new anymore. But there is an aseptic presentation requirement that's been added in there. How many of you go to open up your peanut butter or your ketchup or whatever it is, and it just tears? It's awful. I mean, we're not talking about med device, but the same thing can happen in a hospital or medical setting, right? Where you go to open a pouch and it shears down the middle, like you can see on the right there. Or you can't open it. You're struggling to open it because it's sealed so dang tight. You finally pop it open and now you've lost everything because it falls to the floor because you needed to spend so much energy to get the thing open. Sample size. I would love to talk a lot about this one, but it's very simple what ISO 11607 spells out. The sampling, and I'll just read it to you. The sampling plan used for selection and testing of packaging systems shall be applicable to the packaging systems being evaluated. Sampling plans should be based on statistically valid rationale. I think sample size is probably one of the top questions that I get asked is how many samples do I submit for a package validation? And unfortunately, there's no clean answer. The answer is statistically valid rationale, which isn't very helpful because we like to have that easy number to hit. ISO 16775 more or less says the same thing. So there are a couple methods that, sorry, before I jump there. So there are a lot of things that go into sample sizes, and I have a big long list of them here. It would be great to have 100% inspection of parts, but that's costly, right? It's just not feasible. Maybe depending on each batch size that you make, only a certain number of them could be allotted for this validation testing. If you know that there's a lot of variation in your process, that might require you to say, yeah, we need to up the sample size a little bit. If you have good process controls in place, though, that might help give you justification to say, a process for manufacturing this is really tight, it's really good, so that can be used as justification to reduce your sample size in some cases. If you have a minimum level of deviation, if your confidence level is set to a point where you understand exactly what needs to happen with it, then you can get away with lower sample sizes too. If you have your variability in the population, you might need to increase your sample size. So you can read the rest of these and kind of infer what does contribute positively or what detracts from your sample size. But at the end of the day, there's a lot that goes into it, right? And the main takeaway here is that usually the why or how you got to the number is more important than the number itself. So if you can communicate that clearly, that usually goes over much better with your regulatory bodies if they understand the methodology in which you arrived at that number, assuming they agree to your methodology too. Some tests that we perform, they're either qualitative or quantitative. Data that's qualitative will usually necessitate higher sample sizes. If it's dependent on an operator to judge with their eyeball and say, yeah, this passed or this failed, that's not as reliable as data that will give you a nice hard, fast number. So that can also play into your decision of, for this test, I might have this as my sample size. For this other test over here, it will be higher or lower depending on the qualitative or quantitative method. There are two main methods that I kind of see people use for justifying. These are the statistically valid rationale that's kind of out there in the industry. And the first one is a risk priority number, where you look at your device and you say, what's the risk? Is it high risk, low risk? Higher risk usually requires larger sample sizes, lower risk, lower sample sizes. But you get a number from that, and then you convert it to a confidence reliability interval, and then you convert that to a sample size. ISO 2859 goes over acceptable quality level, and the difference there is it's based more off of your lot size or batch size, and then you can use that to extrapolate out what your sample size should be for validation testing. And then if you're lucky enough, if you have a statistician on staff, they might be able to come up with something that's even newer or fancier or more believable. So those are some of the things that we see people use to justify their sample sizes. So talking about the package validation itself. So you've kind of got your sample size down, you know what your sterile barrier system is, and now it comes time to actually execute a package validation, right? So here are some things that you need to keep in mind. And I like to think about it as telling a story. If you can get your regulatory body to buy into what you're doing, and you can explain it clearly, that's how we see the least resistance coming from the FDA in pushing back on your validation plan. So included in that, you need to say what you're doing, right? Why you're doing it that way, how you're going to do it, when you'll do it, and what you expect the outcome to be based on your validation plan. If you just have a bunch of data and you toss it together in a file and you submit, it's a surefire way to get a letter and say, no, it's not going to pass. So be as clear and concise as you can be in your package validation plan, and you'll have the least resistance as you're going through this process. So your test plan itself needs to describe what you're doing, right? It will include all of your methods that you're using to perform your package validation, and we'll go over those in a second. You need to be explaining why you chose those tests. There's a list of tests that you can pick to meet these different categories that are required. So why did you pick that one versus another one? That test needs to have an acceptance criteria. Are you saying that everything passes? Is it a quantitative result? If it is, then you need to have a number that says, yeah, we actually met, or you didn't, right? You need to include what your device is, what your packaging is. You need to include your time points for testing. We're not just doing baseline testing, right? We gotta get some shelf life data out there. So you gotta know how far out you're gonna be testing. Sample size and aging conditions. Aging conditions is not just we're going to age it, right? But what temperature are you aging it? What's your ambient storage temperature? How long does it need to sit in the chamber to hit that shelf life? And finally, what's the condition of your samples that you're sending? Are you using actual product, or are you using surrogate product? It might be too costly to actually use real product. So do you have an acceptable surrogate that can be used instead that will be appropriate for use? How are you actually running the tests? Can you take it straight out of the standards that you're following, or does there need to be any adjustments to it to accommodate your product, your packaging? And then how do you know what the results are telling you, right? So, and this is key to why I talk about thinking about the package validation at the very early phases of product development, because the package validation is intended to show how the packaging performs through all of its intended use, right? That includes sterilization, that includes handling and distribution, storage, and it needs to include all of your materials that go with it. You can't just have like a stripped down version of your product, use that for your package validation, and expect it to work. So, I like to think about these package validations as a stool with its 3 legs. And those 3 legs are the 3 kinds of testing that you need to do to meet the requirements. So you have to have an integrity test, a microbial barrier test, and a strength test. All of those combined show how effective your package system is overall. And in addition to that, you need to do it over the entire shelf life of your product. Here's a list of the kind of bread and butter tests that you'll include in a package validation. You'll notice that there are multiple tests for each category, and that's why I was saying you're typically just going to pick one of them, justify it, and then you don't have to worry about the others. So if you do a strength, if you do a seal peel and it's appropriately justified, you're not going to be required to do a burst test or a creep test instead. Integrity has the most tests out of all of them. You certainly wouldn't want to do all of them, so pick the one that's most appropriate. And same with microbial barrier. There are a few tests on there. Just pick one, justify it, and make sure it's clearly understood why that's the one that's chosen. We're going to be going through each of these tests individually so you can understand what they are, what the pros and cons for each one, and why you might pick them versus another one. So here's kind of just like a basic flow chart of how you should run your package validation. You start at the top with your final product, as close to final as it can possibly be, which means it's post-sterilization. From there, you'll perform your distribution testing. This is simulating the actual distribution of your product, right? If you have a failure in distribution, you need to go back up to the top of the list because something went wrong in there if your system is failing just through routine shipping, right? And then post-distribution, you'll run your baseline testing, and this is going to give you a good benchmark for how's my product performing fresh off the assembly line, per se, right? And then you'll do real-time aging, which is literally aging your product at real-time conditions for the duration of what shelf life you're trying to set. Accompanied with that can be accelerated aging. I don't expect everyone to want to wait 5 to 10 years before they can actually market their product. So accelerated aging is a way that you can actually bring it to market much sooner. So this is key. Just any test method that you choose, say you're doing this in-house, right? It needs to be validated. You can't just read the standard, follow it, and say, ta-da, we met the standard requirement. You need to show that it's validated with these 3 pieces in there, right? So it's repeatable. So if multiple people, personnel within your lab, are performing this test, you can show that despite other people performing the test, you can still get the outcome that it's expected. Reproducibility means that you could send your method somewhere else, and they can also achieve the same thing that you're doing. And this is, I see this come up more and more, is sensitivity. Is your method needs to be sensitive enough to pick up the defects that may exist. I've seen more pushback about sensitivity than any other category, especially with microbial barrier tests. You need to demonstrate that, yes, if there is a failure, we could pick it up. If you want to go to the individual standards that were these methods that do have consensus standards, you can look at these precision and bias statements to address any variability that's in there. And some of the test methods aren't actually going to give you meaningful data. These are your tests like distribution or aging. It's just an exposure to certain conditions, right? If you run a shelf life test, if you age something, congratulations, it's aged. But does it pass, right? That's when you need your integrity, microbial barrier, and strength tests to demonstrate that your serobarrier system is still functional, it's adequate, appropriate. So there are 2 ways I like to think about doing this. You could either do a normal approach, which is taking some of those consensus standards, 1 for each category, running it, and then compiling your data and submitting. This is probably going to be your smoothest path to a submission. If you want to be a maverick and do test methods that don't have standards, or choose something in your plan that's just outside of the norm, you're going to run into a lot more roadblocks trying to get it submitted. But that being said, there are a lot of new novel devices being made out there, and the test methods that have worked for years and years and years may not work for your device. In that case, it may be appropriate to actually have a method that's different or altered from what the normal would be, right? Both can be appropriate to use. Just keep that in mind as you're preparing your submission. Certainly, there is the more you can go with a normal approach, the more familiar it is to reviewers, and the less pushback you'll receive as you're submitting. So let's go through the test methods. Transportation and distribution. These are simulating the actual physical hazards that your shipper box would encounter as it's going through its normal routine distribution, and it's just bringing it into a lab environment. So temperature, humidity, altitude, shock, vibration, compression, these are all things your package might experience, and it needs to survive all of them as it goes through the process. Is that box on the right, did it pass? We'll talk about that. There are 2 main standards to follow for distribution testing, ASTM and ISTA. And both of them require you to follow a certain distribution cycle. The distribution cycle includes the method of shipment. So if the most common one is DC-13, which includes truck and air shipments. If you know that there's train or other modes of transportation, it might be included in a different distribution cycle. DC-13 is probably about 90% of what we see. And within that, you can choose different assurance levels, and that's going to be just how strict, how intense the testing will be. Assurance level 1 is the most conservative, meaning it's the strictest testing. So if a drop height would be at, say, 12 inches before, now it's at 16 inches, right? You're dropping from a higher a higher height. You're adding more compressive force onto it. It's just a more extreme exposure. Assurance level 2 is kind of a middle of the road approach, and it's what most people go with. It's what we recommend. And if for some reason you know that your shipping distribution cycle is really not that extreme, assurance level 3 is the least stringent testing. So if we look at those two boxes there, right, which one fails a distribution test? It's hard to say, because really, what's in that? It's your sterile barrier system. And just by looking at the box alone, you don't know the performance of your sterile barrier system at all. So this is your acceptance criteria for distribution testing is going to be set by you with whatever your user-defined criteria is. If you know the box on the left will most likely lead to a package failure in your sterile barrier system, then you can throw it out as soon as you see something like that. But you may have done the testing and shown that, hey, even if the box looks like this, the sterile barrier system is actually robust enough that it would survive that. So it all depends, right? So the different hazards included in distribution testing is your climactic stressing. The most common temperature cycles that you include are a cold cycle, which is about minus 30 Celsius, a humid cycle, which is 40 Celsius, and 90% humidity, so very, very humid, and hot and humid, or hot and dry, which is 60 Celsius, 15% RH. So if you're a corrugated shipper, is going through like the swamps of Florida and it's really humid, that will certainly impact the performance of your shipper. It might absorb all that moisture. It may not be as resistant to those compressive forces and lead to failures, right? So that's why we use those climactic stressing to evaluate it. Drop test, you don't know if the delivery guy is just going to kick it down the road or drop it or whatever, right? So we put it on that platform there. It's a hydraulic arm, and it'll just drop out from underneath, and it falls to the floor. Compression, this is imitating that box sitting on the bottom of a pallet, right? It's got the weight of every single box on top of it. Can the bottom box survive the force of everything above it? Vibration, this is one of my favorites because it's a table that you can see the silver platform that pallet's underneath. It'll come up out of the ground and it'll randomly cycle between the different frequencies that a package would encounter either on a plane or a truck. I've ran the train cycle before and it sounds like a train. It's pretty cool. Concentrated impact is an optional test. This is meant to mimic those sorting arms that kick boxes onto different lanes as it's going through the mail system, and you drop a cylindrical mass on it and see if it goes through the shipper box. Altitude testing, this is applicable for non-porous pouches only. If you think about like a bag of Cheetos, if it goes into low altitude environment, it's going to expand. Does that expansion pop open the seal and not your Cheetos won't be non-sterile, but your medical device will. So I've got these little videos included with each of these tests that are kind of just a very quick overview of what they are.
Samples are conditioned prior to testing as specified in the test plan. Samples are tested for compression. Samples are dropped on faces, edges, and corners. Samples are run on the shaker table. Samples are run on the vibration table to simulate truck and air profiles. Samples are also dropped, tested for a second time on faces, edges, and corners. An optional concentrated impact and altitude test may be run depending on your test sample.
All right, let's move into strength tests. So strength tests are really looking at your seal to see how good of a seal it actually is. I've got a big list of some defects that are seen in seals that you should keep an eye out for. If there's a gap or a channel in there, it's a channel that a microbe can pass through, right? If it's non-uniform, if it's not sealed together well, you may have pockets where it also isn't sealed. Oversealing, this is a big one for me, where you can see that we're looking at a Tyvek pouch here. It gets so hot that it melts it together, and they actually bond entirely together. A lot of people will say, "Great, it makes the seal stronger." I've met my acceptance criteria. It's like way higher than what we set it to, but you also have to be thinking about that aseptic presentation, right? Is it actually able to be opened well enough, or is it too strong that it's impeding the ability to present it aseptically? Delamination is when the Tyvek portion of it actually sticks to the film and the materials will kind of shear and come apart together. That's particularly risky because we challenge with Bacillus atrophius spores, and any of these spores trapped in the fiber, they kind of release and break free when delamination occurs. So if this is happening in like a surgery environment, something like that, if it delaminates, it might just, whatever was on the outside might break free as you're opening it. You want to make sure that your width is uniform. It has to be sufficiently strong. It's not just going to fall open against the weight of whatever's in it. You actually have to be able to peel it open if it's meant to be peeled. And then, like we mentioned earlier, it's got to be a nice, smooth seal, no wrinkles that can introduce those defects. So seal, peel, and burst testing are kind of your two main tests that you evaluate seal strength with. A lot of people ask which one to choose. If you've already been performing in a method for a long time and you have lots of data for that kind of testing, we more or less say go with that, right? But if you're kind of coming from the ground up, there are some advantages and disadvantages to both. So peel testing will take that 1 inch wide or 15 millimeter coupon, and you'll just pull it apart and you measure the force. Easy enough, right? The acceptance criteria is usually dependent on what kind of material you're using, and then the failure mode is also included. So some of the things that we saw earlier, like delamination or material break, or if it's a nice clean peel is the failure mode. For burst test, the whole package is inflated until it bursts open. And it's also the acceptance criteria is also dependent on the material, but also the shape and size of your package. Much smaller packages will perform much differently than larger ones, right? So
Seal peel is a strength test for the seals of both porous and non-porous packages. A portion of the seal is cut from a package and pulled apart on a tensile testing machine. The force required to separate the seal is recorded. This is a graph of a typical peel. The maximum force is the highest force value on the curve. The energy is the area under the curve. The average peel is the average force from the middle of the curve. Most samples will peel apart cleanly, and the mode of failure is reported as peel. When a sample stretches, it is reported as elongation. When the layers of material split apart, it is reported as delamination. When the seal strength exceeds the material strength, the material will break rather than peel apart.
Seal peel. I'm looking at my clock, and unfortunately, I don't know if we have time to view the rest of the videos, so my explanation will have to do for now. I apologize. Your next category of testing is integrity tests, and these are meant to show that the packaging itself doesn't have any breaches that would compromise the sterility of your device inside, right? So we already talked about folding. Kind of the big key thing I want to highlight here is most of our integrity failures come after the sealing process, and it's the interaction of the product with your sterile barrier system. Bubble and dye testing can be influenced by the person performing the test based on their technique. So it's important to have good technique and a nice validated process that is understood. For when you do encounter failures, you usually have to act pretty quickly to understand perhaps why they came about in the first place. Specifically with dye tests, the dye will wick straight through a channel if there's a channel, and then whatever dye is left over will inevitably migrate across the seal so that failure can be obscured and not be able to see it anymore. So the big difference is bubble testing tests the whole package. Dye migration only tests the seal. when possible, it's usually more favorable to test the whole package rather than just the seal, because like we were talking about, if your device inside is moving, rubbing around, got those sharp edges, that won't be picked up by a dye test, but it will by a bubble. Visual inspection is that third test that's included in there. It's very much dependent on an operator to notice the defect. And typically what happens is we'll notice the defect and say, I'm not so sure, let's confirm it with bubble or dye. So visual inspection alone is usually not an appropriate method to include as part of your validation. But it is good for just evaluating your processes to make sure that everything's in control. Are microbial barrier tests. So these are meant to show that your barrier is good at keeping microbes out, right? And if you have these combination systems where you say it's a poly, a pouch with a porous, like Tyvek side to it, you'll want to test what's the more worst case scenario, which is the porous side, right? These tests are kind of prone to contamination issues because, once again, it's dependent on the operator, and microbes kind of like to have the mind of their own sometimes, as we're well aware of. As far as the testing is concerned, F1608 is for porous, Gurley is for non-porous. Both of them require a 2x2 square that's tested. There's a third test that we run called Aerosol Challenge at Nelson Labs, and this is kind of this can be where if it doesn't fit into those two nice categories, aerosol might be a nice alternative. It's basically a cubic meter chamber. We shower it with spores, and then we do something akin to a sterility test afterward, where we'll take the device, we'll immerse it in media, and check for growth afterward. So you've got to pick one, right? So here's kind of our recommendation for some things to think about as you're picking which method you want to choose. For peel or burst, use whatever you have the most data for, if that's something that you already have. The acceptance criteria for burst will depend on your package size, material, and all that, like we talked about. One of the advantages of peel testing is that if your pouch size changes, it's still just that 1 inch or 15 millimeter coupon, right? So you can keep the same test for different packaging configurations. Integrities, the bubble test is preferred for the reasons that we talked about. It's evaluating the entire sterile barrier system instead of just the seals. And then microbial barrier is pretty cut and dry. If it's porous, use F1608. If it's non-porous, use Gurley. And if it doesn't fit into one of those, you might want to consider something else, like our aerosol challenge. So aging, you need to age your product through real-time aging. If you want to do accelerated aging, it has to be done within, I believe the standard says 90 days of when your real-time aging starts. Or it's the other way around. If you do accelerated aging, your real time needs to start within 90 days. And this is helping you get to market faster doing accelerated aging. And you can mess with the calculation a little bit to, for example, if you take the standard recommendation of 25 Celsius storage temperature and an elevated temperature of 55 Celsius, a year becomes 46 days. You can play with those numbers a little bit to get it shorter to, I think if it's 20 Celsius 55, it turns out to be 42 days or something like that. A lot of people try to mess with that, but at the end of the day, it's really just best to go with what the standard recommendation is, unless you've got really good justification for being something else. If they see that you're just trying to shorten your timeline by messing with the numbers, it's not going to fly. So some other things to keep in mind as you're going through your package validation. If you want to do worst case conditions, that's always preferable, right? Because if you validate your worst case conditions, you can scale it back and have good evidence that whatever you scaled back is also going to be appropriate, right? So stress to seals during sterilization, if you're doing an EO cycle, right? Those injections, the pressure changes is something to consider. Your device weight, are your sharps protected or not? the shape of your device if it's really complex and there's lots of weirdness to it and lots of places to rub. That might be considered more worst case. Method of boxing, how full are you boxing it or how not full are you boxing it? In some cases, one might be more worst case than the other. Size ratio to packaging, we talked about that at the beginning. Making if you know that you have an alternative method of pouching your product that is more worst case, perhaps you run your validation on that. And then your storage conditions. If it normally sits at room temperature, but there are scenarios where it could be hotter, and that hotter means more worst case, perhaps you can run it in those conditions instead. Everything should be final configuration by the time you get your package validation. It's not the time to be thinking about making changes to how you're going to pouch it or box it up, right? You should know what you're doing at that point. And so what is tested should be final configuration, which means you include all your accessories, right? Your IFU, if it's in a shelf carton and the shelf carton's in a shipper box, then it all goes in that configuration. And if you can do worst case sterilization, please do worst case sterilization on there, right? And then send it to the lab. And this is kind of another big one that I want to emphasize a lot. When you send something to be distribution tested, it kind of already goes under a distribution test, right? On its way to the lab that's doing the testing. So you want to protect your shipper box as much as you can, meaning overpack it. So whatever your shipping container is, take that, put that box in a box, as Yzma from Emperor's New Groove might say, right? And protect it as much as you can so that when it actually gets tested, it's in as pristine condition as it can be. So the other thing to keep in mind in the whole conversation of, if you're looking to be more sustainable, economical, and you're thinking about maybe using post-consumer material or you're changing your material, changing those things require a revalidation of your sterile barrier system. So if you change the sterile barrier system itself, right, you need to revalidate. If something in your process changes that impacts it, you need to revalidate. Same with if you're changing your device or your sterilization method. Any of those changes would necessitate a revalidation of your packaging. Some you can get away with; they're pretty minor and won't impact your package validation, and those can be justified. But that's a conversation that you need to have whenever these changes go through, right? Does the change require us to perform a revalidation of this? And just including that note in there that you should review if you're doing a lot of small changes and you've justified out of those small changes, it may eventually get to a point where now it's actually a large change and it needs to be revalidated. So it was a lot of information. I love talking shop with package validations. I couldn't get to everything that I wanted to in this presentation. So I'm in booth 1142. If you have any questions, please feel free to come and talk to me. I also have these fun little slider cards where if you take what your sterilization method is and what your sterile barrier system is made of, it gives recommendations on what the test methods should be for your package validation. I love these. I'll hand them out for free. Don't worry about it. So you can either come talk to me after this or over in the booth in 1142. Thank you so much.